Last video we have discussed about the different types of structures. For example, beam or bar or trusses. In this day we can discuss about the detailed about the bar and frame structures. In this video we can going to discuss about the beam. A beam can resist the axial or lateral or twisting loads. If we consider as a beam element, the structure will be same for bar or beam based on the acting conditions of loading that will be classified as a beam or bar. In beam, if the load is acting axial or lateral or twisting loads, that will be considered as a beam. Here the example of beam will be shown here. They are having a three constraints. One will be a fixed constraint, another two will be a roller constraint, and then they are having a two different types of forces acting on a beam. So based on that, based on the loading conditions, here we want to classify as a minimum number of two elements. So that's why here we are consideration two elements. So two elements, element 1 will be a node 1 and node 2, element 2 will be a node 2 and node 3. Each nodes they are having a perpendicular loads and then twisting loads with respect to the output of deformation and then slope. So these are the inputs and outputs of the beams. Next we are going to find the stress strain and displacement denotations. Stress is denoted in the form of vector by the variable of x direction as a sigma x. Because here we are consideration only one dimensions, the dimensions will be consideration horizontal of x-axis. So that's why we take it as an sigma x. Strain is denoted in the form of vector by the variable of x as e of x. So the stress will be in x direction. So correspondingly the strain also will be in the x direction only. Then displacement is denoted in the form of vector by using as a variable of x direction u of x. So the object is located in the x direction. So everything for deformation or sustain will be occurs in only x direction for a bar elements. Next, we want to find the types of loads acting in a structure. In general, commonly the loads are classified into in three conditions for applying in structures. One is in body force, another one is in traction force, third one is in point load. Body force means it is a distributed force acting on every element volume of your body. For example, unit is force per unit volume. Example of self-weight due to the gravity. Any loads or force acting on every element depends upon the volume of the body. That particular volume body weight will be considered as a load. So that is called as a self-weight of the gravity. Mainly the material behavior is denoted as a density. Then traction force, it is a distributed force acting on a surface of the body. Unit is force per unit area. But for one dimensional problem, unit is force per unit length. Example, frictional resistance, viscous drag and surface shear. So any force acting at a particular surface, for example UDL, UVL, that will be considered as traction force. Point force, it is a force acting at a particular point which causes displacements. So particular point, any loads or force acting, that is called as a point loads. So these are the major classifications of loads. All the loads will be combined into these three categories. Next, the properties of stiffness matrix. The stiffness matrix will be a symmetric matrix. Any element, the stiffness matrix will be in symmetric manner, diagonal symmetric. The sum of the element in any column must be equal to 0. So if you sum the column of stiffness matrix, the value will be 0. It is an unstable element, so the determination is equal to 0. So determination of any row and column will be also 0. So this is the properties of stiffness matrix, any stiffness matrix. So thank you for watching this video.